The strength of a wooden portal frame is being studied. Do you know what a portal frame is? Did you watch my video where we break a wooden portal frame in the lab? So, for example, the strength of a wooden portal frame is being studied. From previous experience, it's found that the standard deviation of failure loads is 135 pounds. The past 8 tests resulted in the following failure loads in pounds. So are these 8 data values? 750, 770, 850, 950, 980, 1000, 1100, 1150. And again, these are all in pounds. So what I want to do here, calculate the 90% two-sided confidence interval on the average. So to finish this sentence, I should say on mu, the 90% two-sided confidence interval on mu. Well, to do this in a calculator, I could put in the raw data. I could put in the raw data as is. I don't have to find the standard deviation or the average separately. Press the stat button right here. And then under edit, if you have any other lists in there, just clear it out. Okay, so put in the 8 test results. Can you see this? What? Okay, 750, and then I believe I had 770, 850, 950, 980, 1000, 1100, 1150. Okay, so I have the 8 data entries in there as list 1. Then quit out of this. So second and then quit. If I want to find the average and the standard deviation, just press the stat button right here. And then go over to calc. It's one variable stats, so choice 1. The list, I called it list 1. Frequency list, don't worry about that, leave that blank. Highlight calculate and then press enter. So the average in this case, the average of all those 8 failure loads is 943.75 pounds. The standard deviation, 143.40 approximately, standard deviation, sample standard deviation. How does that look so far? Okay, for the 90% confidence interval, is this thing focusing? Okay, for the 90% confidence interval, press the stat button right here. Go over to tests. It's choice number 7, so you can press the 7 button, Z interval. Okay, so the input in this case, highlight data and press enter, because this particular feature allows me to call upon the raw data, which remember was list number 1. Okay, so for the sigma part, in this case, remember that from previous experience I found that the standard deviation was 135. That was given. List, it was called list 1. Frequency, leave that as 1. If there's a frequency distribution, then this might not necessarily be 1, but in this case it is. Confidence level 0.90. It's 90% confidence. And then highlight calculate and press enter. And it's giving me the interval right here. The interval from 865.24 to 1022.3. How does that look? What? One other way to do this, if you go into stat, go over to tests. Okay, choice 7, but instead of using data, highlight the word stats and press enter. And this is not going to read the raw data, but rather it's going to read what the standard deviation, the average, and the number of data values is. So the input's slightly different if you do it this way. Standard deviation is 135. X bar, okay, well, you type in the 943.75. Okay, since I already did it using the data feature, I guess it already had the 943.75, but if I hadn't done this previously, then you could manually type in what you know the average to be. Okay, so there are 8 data values, so you'd put 8 here. confidence level 90%. So my point is that if you don't have the raw data, in this case I had the 8 data values, but if you don't have that, then you could use choice 7, Z interval, but you'd be using the stats portion of it, the stats option, not the data option. So that's something that you can play with in your graphing calculator.